Good afternoon. All right, today we're going to do modeling with quadratic functions. All right, so writing an equation of a parabola given 3 points. A parabola contains the points 0, 0, negative 1, negative 2, 1, 6. What is the equation of this parabola in standard form? Remember that standard form of parabola's formula is y equals ax squared plus bx plus c. So we're going to use a system of linear equations in 3 variables to take care of this for us. So the first one we're going to do is we're going to plug this in, the 0 in for x, this 0 in for y into that formula there. So 0 equals a times 0 squared plus b times 0 plus c. So 0 equals, well, this drops out, because that's 0. This drops out, so we know that c equals 0. Plug in for this one, the next equation, and we get negative 2 equals a times negative 1 squared plus b times negative 1 plus c. Negative 1 squared is 1, so we have 1a minus 1b plus c. And then last but not least, we take the 6, plug it in for y, plug the 1 in for x. So this is a times 1 squared plus b times 1 plus c. So we get 6 equals 1a plus 1b plus c. There's our 3 equations. This is all reminiscent of our last unit. So now we know that c over here is 0. So if c is 0, I can plug that into these 2 equations. So if I plug a 0 in for c, I get a minus b. If I plug a 0 in over here for c, I get 6 equals a plus b. So now I'm going to take my negative 2 equals a minus b, and my 6 equals a plus b. Since the b's have opposite signs, same coefficient, I'm going to add these together, solve for a, and a is 2. So I'm going to plug that into either this equation or this equation, your choice. So I'm going to have 6 equals 2 plus b. I'm going to subtract the 2, and I'm going to get b equals 4. So the whole point of this was I need to write the equation in standard form. So that equation is going to look like so I'm going to write my equation. It's going to be y equals. We know that a is 2, so this is 2x squared. We know that b is 4, so that's plus 4b. And we know that c is 0, so you could put a plus 0 on there, or you could just leave it written as 2x squared plus 4x. Sorry, this should be an x. And that is the equation in standard form. Let's do another. All right, let's do another one. So this is going to be 0 equals a times 0 squared plus b times 0 plus c. Oh, yes. So this is going to be 0 equals c. Isn't life nice? We got a good one again. This is going to be negative 2 equals a times 1 squared plus b times 1 plus c, or negative 2 equals a plus b plus c. And last but not least, we're going to have negative 4 equals a times negative 1 squared plus b times negative 1 plus c, or negative 4 equals a minus b plus c. So once again, we're going to plug 0 in for c. So right here, we're going to plug in a 0. So this becomes negative 2 equals a plus b. We're going to plug that same 0 in here. So we're going to get negative 4 equals a minus b. You're going to put those together. Because once again, in the lovely b spot, we have same coefficient, opposite signs. We're going to add them together. Negative 6 equals 2a, or a equals negative 3. Plug that back into either equation. So we'll go negative 2 equals negative 3 plus b. We'll add the 3 over. We'll find out that b is 1. We will now write our equation. Y equals negative 3x squared plus x. And you've got the 0 on the end, so we don't need to include it. So there is the answer to our problem. Then we have word problems. You have to love it. So we're going to talk about a rocket. We're going to talk about rocket 1. And we're going to talk about rocket 2. All right, so campers at an aerospace camp launch rockets on the last day of camp. The path of rocket 1 is modeled by the equation. So the height equals negative 16 times t squared plus 150t plus 1, where t is time in seconds and h is the distance from the ground. So remember, what that means to us is that when we're talking about our ordered pair here, we're going to have time and we're going to have height. Okay, so moving back, so rocket 2, the path of rocket 2 is modeled by the graph in your book on page 210. So you need to look at page 210 in your book, so get out your books. So pause this for a minute while you go get out your books. Okay, so now that you've checked your book, you found out that rocket 2 has a vertex at 580. So that means at 6 seconds is 580 feet high. So if we know that from rocket 2 from looking at a graph, we need to figure out from rocket 1, how do we find that same information? Well, how do we find our vertex in standard form? If you all recall, negative b over 2a will get us there. So negative b, negative 150 over 2 times negative 16 is going to be 150 over 32. Now you get to take and divide that and get me a decimal. So when you do that, my dearest, my darling ones, what did you get? You should have 4.69 seconds. So if you wanted to round that even better into a single second, you'd have approximately 5 seconds, right? So then how high is it? Well, remember, how do you find that y-coordinate? You have to plug that back into the original equation. So we're going to take the height equals negative 16 times, and we'll go ahead and use 5, squared, plus 150 times 5 plus 1. So we have 16 times 25 for a negative 400 plus 150 times 5 for 750 plus 1, or we take 750 minus 400, add a 1 to that, and we have 351 feet. So rocket 1 only goes 351 feet. At its highest point, it's 351. So which rocket flew higher? Which rocket flew higher? It would be rocket 2. Which rocket was in the air the longest? So if at its highest point, this was 5 seconds, so to come back down, it was a total of, that's right, 10 seconds. So it was in the air 10 seconds. How long was rocket 2 in the air? Well, that'd be 6 doubled, so that was in the air 12 seconds. So who was in the air longer? Who was in the air the longest? That's right, rocket 2. All right. Have a great time doing your homework in class. Be respectful of the sub. Thank you, and have a great day. I'll see you tomorrow.